Hello and welcome, my name's Ryan, I'm also known as RM2K Dev. In this video we're going to be going over creating a top-down racing game. So what I've got here is this is just the final product. I'm playing with an Xbox 360 gamepad, so I'll just show you guys how it works. So you can enter a corner and do a drift, you'll see there's smoke. There's also dirt if we go over the grassy areas like this. So that's just showing you guys two of the different effects, and it also it brings them in and out as required. So you won't get any smoke when you're going over the grass. So I'll just show you guys a quick lap of this game. I've been playing this all night. I meant to record this video yesterday, but this is just way too fun, so I spent most of the night playing it rather than actually recording it. Oh, there we go. So you get the idea. This is pretty much what we're going to be creating. If you don't have an Xbox 360 gamepad, that's fine. We also have keyboard controls in this. It's just a lot easier if you play this with a gamepad. There we go. Alright, so let's get started. First thing I'm going to do, this video is probably going to be made up of a couple of parts. The first part's probably going to be getting the player character to work, and then we're going to move into doing like the NPCs and the track, the AI, and then some of those cool physics. The first thing I'll do is I'm just going to grab a sprite. I'm going to call this SPR car. Edit, open add, and I'm just going to grab that out of my car tutorials folder. Now these graphics, I purchased these from, I think it was Graphic River a long time ago when I was working on a racing game called Just Drift. So what I'll probably end up doing for the tutorial is blanking these out like I usually do, so that obviously they're copyrighted, so I can't distribute them with the files. So I'll probably blank those out. So once you've got the car sprite, center that and select OK. The next thing we're going to need to do is make some tires on the tires for the car to basically leave behind. We'll use particle systems for that, so it's very efficient. I'm just going to call this here SPR tire part, and that's going to stand for tire particle. If we edit the sprite, I'll open and add one of these cars. I'll pick the one that has this one here because it has the wheels visible. And then all I'm going to do is I'm just going to take this rectangle and I'm just going to draw a red square over where those wheels are. So we've got some wheels that are probably around this area. We'll have the same on this side, just like that. And then we have these two front wheels here, just like that. So the next thing I'm going to do is just remove this image so it goes transparent in the background. There we go. Now that we've got this sort of template for where the tires will be, I'm going to basically create a dithered pattern using these black sprites. So we're going to have little crosses basically, but we're going to dither them so that we end up with, so you know what, we might not have the crosses, we might just do, what can we do here? If we get rid of this center line here, we could make this good pattern, so we'll do that. So basically we just create this cross-hatch sort of pattern, just like that. Now all we need to do is get rid of these colors that we don't need now, which are the red and white. I know I could use the replace color function for this, but I'm just going to use the pencil for now, since that's just what I had open. We have one of the tires completed. Let's just take that. Oh, sorry, wrong tool. We'll just copy paste that, and we'll paste it over the top of the red one here. Now we'll get rid of that section there. Now we're going to do the same thing for these front tires. So we just put the two crosshatch pattern in there and then cross that out like this. And this is basically going to be what the tire leaves behind on the ground. Now since we're going to be using particle systems and it's going to have an opacity effect on it, it will basically leave behind a really nice cross-hatched sort of effect on the road, and that's going to be our tires. So select OK, center that, and then select OK again. Now the first thing we're probably going to need is a room to drive around on, so I'm just going to create a background and I'm going to load in my tile set. And once again, like I said, I purchased these graphics from Graphics River. You can use whatever graphics you like. Obviously I can't distribute this with with the game because of copyright reasons. So set your tile setup however you'd like to set up, if you've drawn it yourself or if you've purchased it from somewhere. And I'm just going to name that BG tile set. Now let's just create a room. Again, guys, create the room whatever size you like. In my instance here, it's going to be 1280 by 1280. I'll set my snap to 128 by 128. So that's basically a 10 by 10 grid. And I'll come over here to tiles, and what I'm going to do is I'm just going to start laying out this track. So basically for me it's going to be something like this. We'll have a corner here, it's going to come back in, and it's going to go back out. Then we're going to go down a few tiles. We'll come in again. Oh, wrong tile there. Then we're just going to come in. Let's make a turn here. Straight down, around, back out, around. So it's probably a bad design doing it like that. Let's try and keep it as central as possible so that you're in the center of the map, so you've got a little bit of room to drift off the side. Here we go. And what I might do here is I'll just add these little grassy patches, so you sort of have to avoid those, and we'll put that back here, connect that up, and put 2 more of those in there like that. And once you've done that, you can just go ahead and fill the rest with grass or decorative tiles if you want to do some sort of nice map. I'm just trying to do this really quickly so that I can show you guys the process involved of how to actually make these drifting physics work. So that's going to be our game map. I'm just going to, actually one thing, sorry, I'm just going to put a start. There's a start tile here for racing on. There it is. If I delete, there we go. Now we've got the little checkered start lines. So jump into physics, set the gravity to 0.0 for the Y direction, and tick the box that says room is a physics world. And the other thing you want to do is go to settings and change the speed to 60 and the name to just call this RM level 1. Okay, so now we're going to begin some of the base coding. I'm just going to bring up a object that I've already created here just for reference, and I'm going to start creating this for you now. So select objects, create object. We're going to call this one here object car underscore base. Actually, I'm not going to do the capitals. Car base. Give it the car sprite. Tick the box that says uses physics and set the shape to a box. That should automatically put these dimensions around. That's fine. From here we're going to add a create event. Inside of that create event, just say image index equals irandom and however many sprites you had. I think I had 3 sprites, so I'm just going to say 2 because 0 to 2 is 3, and image speed equals 0. Now I'm just going to drop that object on the start line in our room just so that we can test it out and make sure that it actually is not trying to animate that sprite. Yep, so we've got a car over here. The one thing that we're missing is a view, so just jump back into your room here and click visible when room starts and enable the use of views. And I'm going to set this view to let's say 640 by 360, and then the port on the screen is going to be 1280 by 720. That's basically going to give us a double. It's going to give us a HD resolution, but it's going to double the pixel by 2, obviously, because 1280 divided by 2 is 640 and 720 divided by 2 is 360, I think. Yeah, it is 720 divided by 360. So that's going to give us this doubled sort of resolution. The next thing we'll do is jump into global game settings and go to the Windows or Mac or whatever OS you're on. Go to the graphics section and untick the box that says interpolate between colors. That's going to remove the anti-aliasing algorithm that GameMaker applies to the sprites when they get scaled. Basically, sorry, not anti-aliasing, a scaling algorithm. I think it's just bilinear or Gaussian scaling or something like that, but whatever it does, it ends up blurring each pixel into each other and you don't end up with a smooth effect. So one more thing we have to do with these views, just set it to follow the player object and set the H border to 640 and the vertical border to 360. That's going to center the view on our player as well. We'll give that a quick test and have a look what happens. There we go. So now we've got this player and he's centered in the center of the screen. The next thing we're going to need to do is begin by creating some basic code. I don't think we need to do anything in the step event just yet. So I think we're pretty much done with this object. So select OK, and we're going to create another object. This object is going to be called object_player. Now again, we need to give it the sprite of the car and tick the user's physics box. Now this one's going to have some different physics properties, and these are just some numbers that I've experimented with and found work good. So I'm going to set the density to 1, so this makes this car slightly more dense, or has a bit more weight to it. I'm going to select the linear dampening to 0.8, the angular dampening to 3. Now what these two numbers do, linear dampening is going to apply some dampening to our speed x and speed y variables, so we can actually slow down, or we have some sort of friction against the floor. And you would think that friction does this, but friction only applies when you're actually scraping along another physics object. The angular dampening is going to make it so that when another car hits us, we don't end up just spinning out of control. It basically dampens the angles being applied to the object. So now I'm just going to create a step event, and I'm going to add a code segment to that. Just go to Control and drag a code segment in. This is going to be called player input. Now it's important to name these so that when you come back you actually know what the script does. So if you see, if I put those 3 slashes, it now says player input. So the first thing we're going to do is we're going to handle the rotation for left and right. We do this just simply by using if keyboard. So if you're using keyboards, you will use keyboard check excuse me, and the key is going to be VK_left. If you're using an Xbox 360 gamepad like me, I'll show you how to do that also. So if it's VK left or gamepad, and we're going to use axis value. Now the device is going to be 0 because this is the first player. So the first player is always 0, the second player is 1. And we're going to be looking up the value of GP, so if that's gamepad, axis left H. So that stands for, I think it stands for left horizontal, because we're looking for the left analog stick and we want the horizontal axis. Now once we've got that value, we actually need to check that it's less than negative 0.5. Now the reason I'm doing 0.5 is it gives it a little bit of dead zone, so you don't just touch the controller and it just responds immediately. You want a little bit of play before you actually before the character starts to rotate. And that's got to be negative 0.5, sorry. So basically, in the center of the gamepad, when you're not touching that joystick, the thumbstick, that's 0. If you go to the left, it starts to go negative 1, negative 2, negative 3, negative 0.1, negative 0.2, negative 0.3, all the way across until it's negative 1. When you start to go right, it goes positive 0.1, positive 0.2, positive 0.3, all the way up to positive 1. And that's how we determine left and right. So obviously if it's less than 0, or I'm saying 0.5, negative 0.5, we're going in the left direction. Now what we're going to do here is we're going to rotate, so we just say PHY rotation is going to be plus equal, and we're going to bring this value back. We're going to use this value here. It's going to be 2 multiplied by that. So we just say 2.7 multiplied by this number here. And what we also should do is we just can say plus 1. Now what this means is that if this number here is 0, it's always going to be 1 because we're adding 1 to it. Now if it's 1, it's going to be 2. So we're going to be multiplying this number here by 2, so 5.4. That was just a guess. I can't do that in my head. I'm a programmer. So now, as you'll see, if we get our gamepad going, sorry, my gamepad's not working. We have to have a look why. All gamepads less than 0.5. physics rotation plus equals that multiplied by that. That should be right. Let me just get rid of this and see what happens. Ah, sorry, of course. I have to put the player in the room. So quickly jump back into your room and get rid of this because that was the base object. We need to put the player object there instead. There we go. And so I just brought this line back to how it was. Sorry, it was 2.7 multiplied by the gamepad value plus 1. Now what you'll see is that we're getting some issues. That's just because we've changed the sprite and we haven't inherited the events. We need to set the parent to be object car base. Sorry about this, guys. We also need to set the view to follow the object player. That's going to fix up our issues there. Right, so now you'll see if I push the left trigger, if I move the left button on my joystick, we're getting some sort of movement here. It's a little bit glitchy, so we need to figure out what's going on there. And I've got a feeling it's probably going to be this this +1 that we have here. So if we get rid of this +1 and have a look what happens. Let's just have a look. There we go. Yeah, it was that +1. That +1 was causing some sort of offset. Okay, so basically if you're using, we can probably do this like this actually. If we just put brackets around all of this and we say it's 1 plus that. So that way for keyboard users they'll always have, there we go. So keyboard users, okay, it's not 1, it's obviously going to be -1. Let's just say -1 plus that value there. There we go. So now I'm controlling this with the keyboard, and now I'm controlling this with the gamepad. Obviously, it's a little bit faster with the gamepad. In a real situation, you'd probably do these two checks separately. I'm just doing them as one, just to show you guys how. Just a simple way of doing this, I suppose. So for my game, I'm going to get rid of the keyboard checks, and I'm just going to use the gamepad. But if you want to do keyboard checks, you just put a fixed number in here. So now the next thing we need to do is check the right direction. So I'm just going to label these here as left turn, right turn. Now on this hand, it's going to be greater than plus 0.5. And then we do the same thing here. We just multiply it by this value, because this time the axis is going to come back as a positive number, and we're going to be turning in the other direction. And again, if I push the controls slightly, you'll see that I move a little bit slower. If I push it fully, I speed up a little bit. So we're getting some sort of dynamic turning as well based on your the user's actual playing input. Sorry, we're getting some feedback based on the user's input. Obviously, we don't want them just to turn at a solid speed. We want them to be able to control it. So the next thing we're going to do is we need to add some force, basically. So we're going to have accelerate. I'm just going to call this gas, actually. It's easier to spell. There we go. Now to do this, we do the same thing, except this time we're going to be looking for that top right trigger, and that's what I'm going to use to do the acceleration. So I'm just going to say if, so a template there. And this is going to be gamepad button value, because this time it's a value, it's not a trigger. And it's going to be player 0, and it's going to be GP shoulder RB. That's going to stand for the right bumper, I think it stands for. I think they've got these inverted in this version of GameMaker, so just check your manual and you'll find out the exact value you need there. I'm going to say if that's greater than 0.1, then we're going to do this acceleration. So the first thing we need to do is work out our forward direction. So if we say forward underscore x equals length dir x, and what we're going to do is we're going to move forward 155 pixels, and it's going to be in the direction of negative phy underscore rotation, and I'm also going to subtract 90 degrees from this. And the reason I'm doing that is because GameMaker treats 0 as facing right, but because our sprites are facing down, I have to offset it with this 90 degrees. We're also going to do this for forward y. There we go, forward y. Now, in order to be a little bit more efficient in the way that I handle speed multiplication, I'm going to call this speed multi equals, and then I'm going to put that, actually I might just call this Excel or gas value. There we go, that's a little easier. And instead of doing a check every time I want to use this value, I'm just going to use that value that we got from the start of this if statement. So if gas value is greater than 0.1, then I can also multiply these by gas value. What that's going to do is that's going to give you a dynamic throttle, because the trigger is also a value from 0 to 1, based on how far you've pressed it in. So if it's not pressed, it's 0. As you start to press that trigger in, it goes 0.1, 0.2, 0.5, 0.6, all the way up to 1. So obviously, the result of this forward length, basically, we're traveling 155 pixels forward in the direction of negative rotation minus 90, 155. Anything multiplied by 0 is going to be 0. As we start to step on that throttle, or the gas, we're going to be going up to 0.1. So this time, instead of being 155, it'll be 155 multiplied by 0.1. So it'll be a smaller value. What that will do is it'll give us some dynamics in our acceleration, so we can actually adjust the amount of acceleration we're giving the player. And now simply all we need to do is say physics apply force. It's going to be at position X and Y. I'm using GameMaker 1.3. I think they've fixed up those differences now. And it's going to be in the direction of forward X. Let's make sure I spelled that right. Forward X and forward Y. Let's quickly run our game and have a look and see what we've got. So now, as you can see, we can accelerate. If I let go, we slow down. This is due to the linear dampening. And you'll see we're actually able to get some sort of drifts going at the moment. So we can do some donuts, something similar to that. We follow our track around. I haven't played this track yet, so you have to forgive me for sucking at it. I've only played the track that I made in the other version of this game. There we go. So we've got some drifting going around these corners. There we go. And back to the start line. And if I let go of the trigger, you'll see that we slow down. Now if I press the trigger very slightly, what you'll notice is we can actually move the car at a very slow speed, and this is that dynamic throttle I was telling you guys about a second ago. If I start to push down the trigger harder, we get a bit more acceleration, and if I push the pedal all the way down, we get full acceleration. And this is how that dynamic throttle helps us. It gives you a bit of control, especially when you're going around the corners and you actually want to start tapping it just to slow your speed down a little bit. You get a bit more control out of the car, and it also makes for a more realistic and fun drifting sort of experience in this game. I think that's pretty much going to be it for the basis of setting up our player. Oh, sorry, one more thing I forgot to do. We need to add an event inherited at the bottom of this. This is just because we're going to be handling the particle systems and things like that inside of the base object. So at the end of our step, we want to execute the parent step event, basically. So thank you guys for watching. Please like this video and subscribe to my YouTube channel. I hope you guys enjoyed this. If you do want to see any more features in this game, please wait until you've completed the series. So it'll probably be 3 or 4 parts, and then leave your comments in the final video, because I've started to have a bit of trouble keeping up with all of the comments since starting these tutorials. I'm getting a lot of help requests and feature requests, and it's getting really hard to maintain all those comments. So if you guys could hold out for the feature requests until the final video of this series and put them all in one place, I'll be able to see them much easier. So once again, thank you guys for watching. Hope you enjoyed the video. Please like and subscribe the video. Goodbye.